is there's a power line. So line, let's call this point A, B, okay? And then there's a lamp. I'm going to put that at point C. So you're given all the coordinates. And we're trying to figure out at what point on the power line should the cable from the lamp be connected. So we're trying to figure out what this point is. The shortest distance from a point to a line is what? The shortest distance is always what? Is always perpendicular, right? So we're actually trying to figure out what point should the cable be connected, and it has to be the point that has the shortest distance from the lamp to, it has to touch the power line. Okay, so if they connected the cable from the lamp all the way to, let's say, here, that's not the shortest distance. They want to connect the cable the shortest distance possible from the whole power line, okay? First things first is we have to find this point, and then the question also asks us to, it says, if each unit represents 1 meter, how much cable will be needed to reach the power line? So once we figure out this point, what's next? How much cable? What would you be calculating if you want to know how much cable you possibly need? The length. We need to know the length of the cable after. Okay. We don't know. We don't know what the equation of the line where the cable is. We don't know how much cable we need. We don't know where to connect the cable. We have to figure out the equation of the cable. That's our goal. We need an equation of a line for the cable so that we can calculate the distance, and we need to figure out the point of intersection. Where does it touch the power line? Does that make sense? Okay, so if it's the shortest distance, we know it has to be perpendicular to the power line. So first things first, what do we have to calculate? The slope, right? We've done this before. This is just has a few extra steps. We need to find the slope of the power line because we know that the cable has to run perpendicular to the power line. So the first thing we're going to do is we're going to figure out what is the equation of the cable. So we'll start by finding the slope of the power line. Okay, so that's the easy part. So I'm going to call it, I called it AB, XY, XY, plug in the variables, plug in the coordinates, y2 minus y1 over x2 minus x1. This is going to give us the slope of the power line. So 10 take away 4 over 12 take away 0. What is the slope of the power line? 6 over 12, lowest terms, 1 over 2. That's the easy part, right? Slope of the power line is 1 over 2, which tells us what? How does that help us with the cable? How does that help us? So if the slope of the power line is 1 over 2, what does the slope of the cable have to be? Slope of cable is -2. Okay? So now what do we do with that information? Yep. So we're going to find the equation of the cable using the coordinate of C. We know one point on the cable. Do you know this point? Do you know the point where it has to be connected? No, we don't. We know the lamp is at 619. We know the slope is -2. So we're going to use that information and we're going to plug it into y equals mx plus b, and we're going to solve for b. Does B tell us this point? No. What's B? B is a y-intercept, right? So we actually have to do an extra step after that. If I were to extend this line, it would intersect at positive 31. That line would intersect at 0, 31, right? Okay, but now what? We are trying to find this point. So think about this. We're trying to find the point where the cable intersects, so it touches the power line. We're trying to find the point of intersection. So we're trying to find the point where these two lines intersect. To find a point of intersection, we need to know the equation of two lines. Well, we know the equation of the cable is y equals -2x plus 31, right? We just figured that out. And thank you, Ashmita just reminded us, well, we don't know the equation of the power line. We know the slope of the power line is 1 over 2. So we know that the equation is y equals 1 over 2x plus b. We have to figure out b, right? In order to find the point of intersection, we have to have two equations of the lines. So let's go back, and now we have to find b from the power line. So this point here is 10.8, 9.4. So that is the point where the cable has to be connected to the power line. The second part of this question said, how much cable do you need? Well, we know that the cable is connected from 619 to 10.8, 9.4. How do we figure out how much cable we actually need? This is all we know about the cable. The slope is negative 2. Thank you. So we're going to figure out the equation of that line. That's the first step. Plug in your x and your y and m, and we're going to solve for b. Okay, so b is equal to 31. So the equation of the cable is y equals negative 2x plus 31. And if you look back at the graph, I'm going to go back to look. Does that make sense? Let's see. Let's look. Okay, so we know the slope of the power line. We know two coordinates, and as I was drawing this, I realized, well, do they give us the y-intercept? How do you know that this is b? Because what? It starts with 0. The coordinate starts with 0. So they actually give us b. So what is b equal to? 4. So yes, in this case, we don't have to find b. I'm not going to go through the steps to find b because, you know, we just did that with the other question. So we know the equation of the power line is y equals 1 over 2x plus 4. We're trying to figure out at what point do the power line and the cable intersect, because they have to figure out where do they have to connect the cable. At what point on the power line should the cable from the lamp be connected? So we have to find this point of intersection. And okay, so we can use substitution to find the point of intersection of these two lines. We want to figure out where they intersect. So you want to use substitution. So I'm going to substitute. It doesn't matter which order we do it in. Do you want to substitute this into the first equation? Sure. So instead of writing y, I'm going to write the value of y, which is 1 over 2x plus 4 equals negative 2x plus 31. Now we need to rearrange the equation and isolate x. Okay, so rearrange the equation, 1 over 2x, negative 2x becomes positive 2x, 31, and then positive 4 becomes negative 4. What's a half plus 2? So I'm going to write it as a decimal, 2.5x, right? 2.5 equals 31 take away 4. Divide by 2.5, divide by 2.5, x equals, yeah. So for the point of intersection, I know that it's located at 10.8 something. So to find y, I'm going to use this equation because it doesn't have fractions. Y equals negative 2x plus 31. And then all we're going to do is plug in, we're going to substitute x into the equation. Does it matter which equation we use? No. So y equals negative 21.6 plus 31. Y equals 9.4. So therefore, the point of intersection is located at 10.8, 9.4. So let's go back to the graph. Well, now we know where the cable is located. We have to find the length of it. So we're going to use the distance formula. So distance equals x2 minus x1, so 10.8 minus 6 squared, plus y2 minus y1 squared. Simplify it. Let me just finish this question. 115.2, the square root of that is 10.73 approximately. So she's right. You would need approximately 10.8 meters of cable because you don't want to have, if you only got 10.7, you would be short cable, right? You need a little bit more.